In July, scientists discovered that dark oxygen is produced on the seabed. This discovery, published in the magazine Nature, might completely change our understanding of the deepest part of the ocean. But what is dark oxygen? And why is it so important? Let me explain. Chapter 1. What do we know about the bottom of the ocean? Well, not that much. Researchers often say that traveling to space is easier than plunging to the bottom of the ocean, mainly because of the pressure, which makes the attempt of going so deep extremely dangerous, and also because of the cost of the technologies needed for such an adventure. The ocean surface has been explored for tens of thousands of years, but only 23.4% of the seafloor has been mapped, according to the 2022 figures from the National Oceanic and Atmospheric Administration in the US. Scientists divide the ocean into 5 different layers. So the first is the epipelagic zone, also called the sunlight zone, and is 200 meters deep. The second one is the mesopelagic zone, or the twilight zone, and extends from 200 meters to 1,000 meters. Then there's the bathypelagic zone, or midnight zone. This zone extends from 1,000 to 4,000 meters, and this third layer is the beginning of what is considered the deep sea, because it has no light. The only light at this depth and lower comes usually from the bioluminescence of the animals themselves. The fourth zone, from 4,000 to 6,000 meters, is called the abyssopelagic zone. As a side note, the name abyss comes from the Greek word meaning no bottom, because they thought the ocean was bottomless. In actuality, 3/4 of the area of the deep ocean floor lie in this zone. The final zone is the adalpelagic zone, which extends from 6,000 meters to the very bottom at 10,994 meters. That depth is in the Mariana Trench of the coasts of Japan. This region name comes from Hades, the Greek god of the underworld. Although it's impossible to know for certain how many sea creatures exist, scientists estimate that about 2 million species exist in the Earth's ocean. Of these 2 million, only 10% have been discovered by scientists, according to the Ocean Census, which is an initiative that records and discovers marine life. Currently, there's also an effort on the way to create a definitive map of the ocean floor. It's called Seabed 2030. Chapter 2. What is dark oxygen? This July, scientists discovered something that they call dark oxygen on the ocean's floor. Everything started in 2013, actually, when Professor Andrew Sweetman from the Scottish Association for Marine Science found that oxygen was being produced on the seabed 4,000 meters below the surface, where no light can penetrate. At first, he thought his equipment was not calibrated. What bugged him was the fact that previous studies conducted in the deep sea have shown that oxygen is only consumed but never produced by the organisms that live there. In fact, photosynthetic organisms such as trees, plants, plankton, and algae use sunlight to produce oxygen that cycles into the ocean depths. So where there is no light, of course, there is no oxygen being produced. So now his team is challenging this long-held assumption, finding oxygen produced without photosynthesis. Hence why they call it actually dark oxygen, because it doesn't need any light. For this study, the team took some samples of sediments, seawater, and polymetallic nodules from several locations in the Clarion-Clipperton zone, which is a large area in the Pacific Ocean that extends for more than 6,400 kilometers and is beyond the jurisdiction of any country. So they took those samples and studied them in the lab to understand exactly how oxygen was being produced. The hypothesis that was found was that the nodules were doing something already known as seawater electrolysis. Basically, when electric current is placed into salt water, it can split the water into oxygen and hydrogen. This geobattery hypothesis is considered by many scientists as a reasonable explanation for the production of dark oxygen. However, as with any new discovery, there may be alternative explanations and way more research needs to be done to confirm this hypothesis. Chapter 3. Why is this important? I've mentioned that polymetallic nodules were used in this study. These nodules are rich in manganese, cobalt, copper, nickel, and lithium. And all these metals are sometimes called critical metals because they are in very high demand for the use of solar panels, electric car batteries, many other green technologies, but other technologies just like phones and computers. The US Geological Survey estimates that 21.1 billion dry tons of polymetallic nodules exist in the Clarion-Clipperton zone. This basically means that this region contains more critical metals than the world's land-based reserves combined. The potential is so huge that many companies are interested in deep seabed mining. I actually wrote an article for the Environment Journal, a Canadian online media, about all the controversy around deep seabed mining. I will link it down below for you to read if you are interested. I definitely recommend it very much because not only I wrote this article, but also because deep seabed mining is an issue that is going to become way more important in the future. So it's a subject that is more and more present in everyday news. Now, you probably know already where I'm going, but we start to understand that deep seabed mining can potentially damage the environment underwater and harm midwater ecosystems as well as organisms on the seabed that often live on those nodules. It can also disrupt the way carbon is stored in the oceans, and thanks to this study, we now understand it can put at risk the ecosystem function of these nodules at the deep sea floor. For all these reasons, we see that deep seabed mining might contribute further to the climate crisis. As I said, the role of these nodules is unsure. We don't know why they exist. We don't know why it creates oxygen at this level. But they definitely seem more important than ever. On top of that, I would add that this discovery could inspire fresh ways to think about how life began on Earth. And with that being said, I hope you enjoyed this new video. I'm going to link down below the study I mentioned in this video, my article as I said already, and a few other resources if you want to get a bit more informed in that subject. You also find a Greenpeace petition to stop deep seabed mining if you are interested in partaking in this movement and protecting our planet. Thank you for watching and see you in the next one.